Myself TV Sangeetha, Assistant Professor, Department of Chemistry, KSR College of Arts and Science for Women. So in this video we are going to see the topic of basics of stereochemistry, that is given in the very first unit of organic syllabus of 3rd BSc Chemistry. So before going to see the topic elaborately, first you must know what is the stereochemistry and what are the basic terms involved in this stereochemistry. Stereochemistry is nothing but branch of chemistry that is fully deals about the study of different spatial arrangements of atom and the molecules. That means that is the three-dimensional properties or properties and the reactions of the molecules. So here the some definitions of definitions involved in the stereochemistry. The stereoisomers means the compounds with the same connectivity and having a different spatial arrangements. Next one is the enantiomers. The enantiomers is otherwise called optically active isomers. These are stereoisomers that are non-superimposable mirror images and having a same physical and chemical characters, but those are only differ in the optical characters. Next one is the diastereoisomer. The diastereoisomer compounds are neither mirror images nor superimposable. So these compounds are having entirely different chemical, physical and optical active properties. Next, asymmetric center. The asymmetric center is nothing but the chiral center. That carbon is attached with the 4 different group of atoms or 4 different group of atom or the group of atoms. Optical activity. The compound which is having able to rotate the plane polarized light either in the clockwise direction or in the anti-clockwise direction is mentioned by the term optical activity. The next one is the chiral compound. The chiral compound means the compound which is able to rotate the optical active will be called as the chiral compound. Next one is the polarimeter. The polarimeter is nothing but that is a device that is used to measure the optical rotation of the chiral compounds. Okay, next one is the plane polarized light. So for measuring the optical activity of any organic compound, we can't use the ordinary light because ordinary light can oscillate in all directions. So we should convert the ordinary light into the plane polarized light by passing ordinary light into the Nicol prism. This prism is converting ordinary light into the plane polarized light. The plane polarized light can oscillate in a single direction. So after converting into the plane polarized light, that light is sent to the sample tube. In the sample tube containing very dilute solution of the organic compound. So according to the arrangement present in the organic molecule, the plane polarized light is rotated either in the clockwise or in the anti-clockwise direction. The compound is showing in the kind of responses means that compound is called optically active compound. Suppose the compound is not giving any responses means that is said to be a chiral compound. So next the polarimeter is used to measure the how much angle of rotation is happen. So for that the polarimeter is containing analyzer and the detector. So by using this instrument we measure the optical rotation. After measuring the optical rotation by using this formula, that is alpha by CL, we can calculate how much angle of rotation is happened. Here alpha is the observed rotation, C is the concentration and L is the length of the tube. So if you have a values in the plus sign means that is definitely be the textile rotation or the clockwise rotation. If the value is a negative means that is called a levo rotation or the anti-clockwise rotation. Here we see the some example for positive and the negative rotation. So here the compound penicillin, sucrose, camphor and MSGs are having a positive rotated value. That means these are said to be a textile rotatory compound, and the cholesterol, morphine are having a negative optical rotation value. So these are definitely be the levo rotation. Thank you.